Good afternoon, Year 12. I thought to save you a bit of screen time today, I'd just make you a video because there's nothing new in here. We're just pulling together everything that we've learnt so far in Chapter 10. So I'm going to go through 3 examples for you, and then there'll be a separate video as well showing you how to check your solutions on your graphical calculator. So the first one is exercise 1A from the textbook. Solve the equation for cos squared theta equals 1 within the range 0 to 360. The angle is just theta in the equation, so we can leave the range as it is. But to be able to solve this, we need to make cos theta or cos squared theta the subject. So the first step is to divide through by 4. You can't do the inverse cos function when it's got the coefficient there of 4. So now when we square root it, we get cos theta is equal to the positive and negative roots of 1/4. So we did look at an example like this on Monday on Dr. Frost. Whenever you're square rooting a function, you need the positive and negative roots in this context. So I'm now going to write it out as cos theta equals positive 1/2, so the positive root of 1/4, and cos theta equals negative 1/2, so the negative root of 1/4. Doing the inverse cos function on 1/2, I get theta is 60, so that's my principal value. Thinking about the cosine graph between 0 and 360, if my first solution is 60, then my second one is 360 take away 60, so my second solution there is 300. And that's my first 2 solutions. I then need to do the same for when cos theta is negative 1/2. So inverse cos of negative 1/2 is 120 degrees. That's down here. And then to find the other solution within that range, I need to do 360 take away 120, which is 240 degrees. And those are my 4 solutions within the range 0 to 360. It's always nice to just set it out neatly at the end, list them in numerical order, so 60, 120, 240 and 300 degrees. My second example here is inspired by question 1D from the book, but I've changed it slightly. I've changed the angle to 2 theta. So the first thing that we need to do, if the angle is 2 theta, is to change our range so it's in terms of 2 theta. So we double all of these values to show that 2 theta is between 0 and 360 degrees. Now we've got a quadratic in terms of tan 2 theta. If we can factorise this, we should. If not, you could use the quadratic formula, or you could use the quadratic formula anyway. If you like, you could substitute tan 2 theta for x to show that x squared take away 3x take away 10 is equal to 0, and factorise that quadratic. I know from past experiences with you tend not to do that, so I'm not going to either, but you could. So I'm going to factorise this in terms of tan 2 theta. And our 2 values that multiply to make negative 10 and add to make negative 3 are negative 5 and positive 2. So there are our 2 factors. Now if tan 2 theta take away 5 is equal to 0, then tan 2 theta is equal to positive 5. And if tan 2 theta add 2 is equal to 0, then tan 2 theta is equal to negative 2. And again, we need to solve both of these. If this were a sine or a cosine function, then if either of these values were less than negative 1 or greater than 1, that part of the equation would give us no solutions. But when we're working in the tan function, because it's infinite, we don't have that same problem. So the inverse tan of 5 gives us 2 theta is 78.69 degrees. That's the principal value. Always with our tan function, we're just adding or subtracting 180 degrees to find the other solutions within the range. So I can add 180 to that to get 2 theta is 258.69 degrees as well. If I added another 180, I'd go beyond the 360 degree limit, so I can stop there. For the second one, tan 2 theta is negative 2, and the inverse tan function tells us that 2 theta is negative 63.43 degrees. So that's our principal value for that one, but that is outside of our range. It's less than 0, so it's not one of the solutions that we want. So we have to add 180 to find our next value for 2 theta, which is 116.57 degrees, and then add 180 again to get 296.57 degrees. Now we have all of our values for 2 theta within the given range 0 to 360. We can divide them all by 2 to get our values for theta, which are 39.3 degrees, 58.3 degrees, 129 degrees, and 148 degrees. Making sure that all of your answers are given to 3 significant figures unless specified otherwise. My final example I'm going to show you is question 4b, still from exercise 10F. We're starting off with an equation in terms of 2 trig functions, tan theta and cos theta. The first step, wherever possible, will be to change it into one trig function. So thinking now about the trig identities that we know, that tan theta is sine theta over cos theta, and also that sine squared theta plus cos squared theta is always equal to 1. My first step here then is going to be to substitute the tan theta for sine theta over cos theta. I can now multiply both sides by cos theta to eliminate the denominator on the left, and I get sine theta is equal to cos squared theta. I can substitute the cos squared theta for 1 minus sine squared theta by rearranging this identity. And now I've got an equation which is all in terms of sine theta. Because it's a quadratic, we're going to have to set it equal to 0 to solve it. So sine squared theta add sine theta, take away 1 is equal to 0. This quadratic won't factorise, so now I'm going to have to use the quadratic formula to solve it. Sine theta is equal to, be careful with your coefficients. Here a is 1 because we've got 1 sine squared theta, b is positive 1 because it's 1 sine theta, and c is negative 1. So substitute those into the quadratic formula. Sine theta is minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. That gives us the solutions that sine theta is equal to negative 1 plus or minus root 5, all divided by 2. Now, negative 1 minus root 5 divided by 2 is less than negative 1. So that one is not going to give us a solution, so we can ignore it. The next step in our working out, therefore, is just to work with the solution that sine theta is equal to negative 1 plus root 5 over 2. And when we apply the inverse sine function, we get theta is 38.17 degrees. And there's my principal value. Now we're working in theta. The bit that I forgot to mention at the beginning of this question was the range that we were working within, which for this question is negative 180 to positive 180 degrees. So my principal value is within that range, that's fine. Thinking about the sine wave between negative 180 and positive 180, I can see that both of my values need to be between positive 0 and positive 180. So my next solution is going to be 38.17 subtracted from 180, which is 142 degrees. And there are the two solutions There are no solutions within this range where the graph is negative. So I hope that's helpful. You are applying all of the skills that you've learned so far, solving quadratics, substituting trig identities, so don't forget it's these two here, rearranging, solving equations, make sure you change the range if the angle isn't just theta or x, and finding all the solutions within the given range. Get in touch if you have any problems. I would like you please to do as many questions as you can from 10F. It is worth doing every single question if you can, or at least get as far as you can until you get stuck, and then get in touch. And chapter 10 mixed exercise, start that please for your homework. I'd like you to do questions 5, 6 and 7, and then question 9 onwards, and again do as many as you can, but it is imperative that you do not skip any of 5, 6 and 7, because it's the identities that tend to catch people out. And then question 9 onwards is solving equations, which if you can do the identities, you should be okay with that bit. But make sure you do 5, 6 and 7, and then as many of the rest as you can.